In chemistry in organic compounds, there should be the importance of bracket and seniority of chain. Okay, so before of that we consider the all over the lecture that should be the nomenclature in chemistry, substitute nomenclature, conjunctive nomenclature, additive nomenclature, replacement nomenclature, subtractive nomenclature, radio function nomenclature, locants, general nomenclature, prefixes, prefix bicyclo, commas, colons, hyphens, full stop, spaces, examples, and then we italicization in nomenclature, words and syllabus, importance of vowels. Now we have to consider order prefixes, and then we have to consider importance of bracket. So brackets, if we consider the numerical, that is algebra, so there we consider that is Bodmas rule, and according to Bodmas rule we calculate all over the calculation. So there should be, we see that is many brackets are there. So brackets are basically three types. There should be these small brackets, this type of brackets can be used, see, and this is type of brackets can be seen. If you know the keyboard of laptop, computer, or any type of mobile phone, so you can see this type of brackets are also there. That is, there must be three types of brackets can be there. Okay, if we consider this type of bracket, this is also termed as small brackets. Okay, or curves. Curves are not we use so much, we use basically small brackets. So placed around prefixes defining substituted substituent. If some substituents are there, so to denote these prefixes that this position substituted substituents are present, so that's why we use small brackets or curves. Next one, placed after the numerical multiplicative prefixes like beasties. So there should be beasties, so placed after the numerical multiplicative. These beasties, after that we can use small brackets. Placed around simple substituent prefixes to separate the locants and to avoid ambiguity. If there must be any confusion, if there must be any ambiguity, so to avoid ambiguity, there are small bracket placed around the simple substituent prefixes to separate only the locants. Okay, and placed in acid clarity. Okay, this is the acid. For clarity we can use bracket, small bracket. So there should be four cases are in general, that is placed around prefixes defining substituted substituents, placed after the numerical multiplicative prefixes like beasties, etc. Then placed around simple substituent prefixes to separate out locants and to avoid the ambiguity, and placed in acid clarity. Okay. So there should be so many examples are there. First one, Cl-CH2-SiH. So when any compound having SiH group, so this is termed as silane group. When any compound which having SiH type of group, so that should be termed as silane type group. Actually silane is a structure of SiH4. Okay, so there should be hydrogens are replaced. Okay, so we get silane, chloromethylsilane. Okay, because carbon, silicon in the same group. Okay, so having the same type of valency can be shown. So I think this will be the H3. Okay, so that's why chloromethylsilane. So why bracket are used? Due to position, justify the position, and due to giving the indication there should be chloromethyl unit is present with silane group. Actually this is the silane derivative, but derivative is chloromethyl. That should be dictated by the small bracket term. Okay, so actually the compound is silane, and but this silane is substituted by chloromethyl group. This signified by the small bracket term, small bracket, that is chloromethyl in bracket then silane. Next one, there should be in bracket, in this is not a small bracket, this is actually third bracket, whole twice CH, okay, so this is a third bracket. But in when we consider the naming, we taking the small bracket. So they are B's in bracket 2-hydroxymethoxyacetic acid. So 2-hydroxymethoxy, because if we consider OCH2 group, this is nothing but this is a methoxy group, and in that position OH is attached, so we can term as 2-hydroxymethoxy. Okay. Acetic acid, because this is the derivative of acetic acid. As we know, that is, this is CaC COOH is the acetic acid. There are 2 hydrogens are replaced by 2-hydroxymethoxy group. So we can say that is B's 2-hydroxymethoxyacetic acid. B's is a prefix to denote that there should be two times 2-hydroxymethoxy unit is present in the structure of acetic acid by replacement of 2 hydrogen. Okay. So there should be first bracket introduced after the B's prefixes. We already know there should be given the replaced after the numerical multiplicative prefixes like B's and T's. When we introduce B's, T's like prefixes, after that we can use small bracket to introduce this type of unit is present 2 times, 3 times, so on. Okay. Next one, CaCSiH2Cl. There is right indication can be there because there silicon is tetravalency. But here anyhow I mistaken silicon as a divalency, is actually silicon is a tetravalency because silicon is present in the group of carbon. So silicon do not show any anomalous behavior which is not matched with the group, right? So silicon always show 4 valency, tetravalency. So there must be silicon is tetravalency can be justified. So chloro in bracket methyl silane, because this should be justified, that is silicon is attached in one place chlorine group, and methyl group in bracket means that is methyl group is another group which is attached with the silane moiety. If there bracket is not introduced, it indicate that is methyl group attached with chlorine group, but actually not that. That is silane having one chloro group and one methyl group. That should be indicated by the small bracket. Okay. This is H. 3. Next one, SH, SC, then CH2, CH2, C, SSH. That should be butane bis dithionic acid. Now you can say what is the dithionic acid? You know carboxylic acid, this is the carboxylic acid. But when we introduce C double bond S and there should be SS, that is termed as thionic acid. Okay. And as there must be 2 C double bond S and SH group is present, so we can say that is dithionic acid. Okay. And butane, why we say butane? Because if we numbering 1 carbon, 2 carbon, 3 carbon and 4 carbon. So 4 carbons are there, so we can say butane, and 2 thionic acid are there, thionic acid group is there, so B's in bracket dithionic acid. Okay. As there should be 4 carbon in chain, so we can say butane, and as there is 2 thionic acid, that is C double bond S and SH, so we can say B's in bracket dithionic acid. Now consider why first bracket is introduced, because we know that is after using B's we have to use in bracket the term dithionic then acid. Okay. The overall compound is acid, so it is outside of the bracket, but we have to mention that is which unit is present in 2 times. That's why we use B's term. So we have to consider this B's term, that is dithionic, in bracket first bracket. Okay, or small bracket. Next one, there should be dithionic. Thionic acid means nothing but that is C double bond O. This O is replaced by S, and OH is replaced by thiol group SH. Okay, that should be termed as thionic acid. Now consider 12 carbon HCl3. That is called 12 carbon chloroform. We know that is must be CH. Cl3 is generally termed as chloroform, but we have to use but here 12 carbons are given. So 12 carbon means what? Carbon having isotope. Isotope means their Newton number is same. Okay, proton number that should be vary. That's why atomic number also vary. So carbon can exist as basically 12 carbon and 13 carbon. But their physical and chemical properties almost same, so they are considered in the same group. Okay, they are not present in the different group, and they are actually the same element, but their natural abundance are defined. Basically in carbon, 12 carbon I think to 98% natural abundance, and 13 carbon 1.1%. Okay, almost. So natural abundance of 13 carbon is not same. They are natural abundance that should be varying. Due to this, we mass spectra or mass spectra we get the defined intensity of the peak. Okay. So, but there are some characteristics are not same. We have to mention there must be 12 carbon is not NMR active because I overall spin is not divided by 4. There must be that some trick is there. If I, the value of I is divided by 4, means they are NMR inactive. But if does not divided by 4, so they are most probably NMR active. Okay. So 12 carbon is NMR inactive as divided by 4, and 13 carbon is NMR active. Okay. So as there 12 carbon is specified, that is this carbon, that is this chloroform having the carbon is nothing but is it only possibility, that is 12 carbon. So we have to mention in small bracket 12 carbon, then chloroform. Okay. So next one, that is 4 hyphen in bracket thioacetyl benjamide. This is, if we consider this structure, the simplest structure is nothing but this is a benjamide, because there should be having benzene ring, and that is must be C double O, and there should be NH2 group. Okay, but this is one hydrogen is replaced. There should be the hydrogen, and this hydrogen is replaced by C double bond S CH3 group, and this C double bond S and CH3 group is nothing but this is a thioacetyl, because as we know that is CH3 C double bond O group is termed as acetyl. Okay, this is termed as acetyl, and as this oxygen is replaced by sulfur, so we can term as thioacetyl, and that should be present in 4 position. How we can derive? That is at C double O group is 1, so this should be 2, 3, we have to consider this side 1, 2, 3 and 4. So 4 carbon bears the thioacetyl group of the benzene. Okay, so that's how we termed as 4 hyphen in bracket, that is small bracket, specify that is there should be thioacetyl is substituted, and then benjamide. Why benjamide is not in present in bracket? Because benjamide actual the structure. Okay, but one hydrogen is replaced by thioacetyl group. That's why at 4 position of the benzene, so we termed as 4 hyphen in small bracket the unique thioacetyl, then bracket closed benjamide. Okay. And why we termed thioacetyl? Because we know that a CH3 CO group is termed as acetyl group, AC, capital A, small c. But when the carbonyl oxygen is replaced by sulfur, we can term as thioacetyl, because one oxygen is replaced by sulfur, so we term the prefix as thia, right? And due to combination of thia and acetyl, we get thioacetyl. Okay. Sorry, this. Okay, so there should be phosphine hyphen 2,1H on. Okay, there should be double bond O is there, so on, and that is at 2 position 1H is absorbed. So if there in any position hydrogen is there, that means there must be some addition process, hydrogen is absorbed, and to specify the hydrogen is absorbed, we can use small bracket. Next one, square bracket, or we can say this is third bracket. Okay, square brackets used to enclose description denoting fusion site in names of fusing. If the 2 rings are fused to each other, that is there should be 2 sharing carbon atoms are there, that should be termed as fusing. When suppose benzopyrene, okay, so there should be 2 carbons are in common of the 2 rings, so we can term as this is the fused ring system. Okay, 2 rings are fused together. So square bracket used to enclose the description denoting the fusion site, at what position these 2 rings are joined together. Okay, that should be termed as square brackets. If we consider in any two homes are there, two buildings are there, in between of them there should be one wall is there, and this wall is denoted by square bracket. This is the example. Okay, suppose in two country is there, so in between of two country there is this one border area is there. This border area can be designated by square bracket. This is the example. Okay, next one, used in some spiral compound. For spiral compound we know for in a square bracket we have to use, that is small numbering, then bigger numbering. Okay, small number of carbon atom present in any ring, then higher number of carbon atom present in the other ring. Place to enclose the locants for structure features of compound. Sometimes locants that should be are enclosed due to giving the structural feature of the compound. Okay, also used to indicate repetition of group in a chain. Suppose one chain is repeated again and again, so suppose di substituted are there, so for these cases we can use square bracket to specify this. Okay, place to enclose substituent prefixes in which small brackets or curves have been employed. If small brackets are already there, so we have to consider other type of things which can be used to specification, so we can use square bracket. So there should be lots of example. We know this is the fusion site. Okay, so for fusion site there should be dibenzo in bracket B comma E, that is oxopine. So there should be two benzene ring is fused together. So in bracket this B and small e is nothing but that should be denoting the fusion site where the rings are attached to it. Okay, in furan 3 comma 2 and hyphen B, that is also show the fusion site where the two rings are attached together. This is also show the fusion site, and these 4 hydrogens show at that position, at 1 and 3 position their hydrogens are adso. That should be showing by the third bracket. So there should be spiral compound. We know that is the lowest number of carbon atoms should be written first, then highest number of carbon atoms. Okay, so 3 first written, then 4. In bicyclo there must be highest number carbon atoms are written, then mid number, then lowest number. So 2, 1, 0. This is the descending order have to be maintained in bicyclo compounds, and in spiral compound we have to maintain ascending order. Then bases. Bases means this second bracket. Bases may be employed to enclose substituent prefixes in which square brackets are already been done. If square bracket already in done and also small bracket also done, on that case for specification we have to use third category, that is bases. Okay, so there should be NH2 hyphen CH2 hyphen CH2 hyphen O hyphen CH or CH3, then O CH2 all over the compound, which having, if we have the IUPAC nomenclature, 2 hyphen in bases, 2 hyphen in bases, 1 hyphen in small bracket 2 amino ethoxy, bracket close, then ethoxy, third bracket close, ethoxy, bases, then propanitrile. Okay, nitrite. I think this name is wrong. Okay, so there should be, this is the third bracket. Okay, so we use first bracket, we use third bracket, so we have two specification, we use brackets. Okay, there should be 2 amino ethoxy group is there, that is if we consider this group there should be 2 amino ethoxy, that is the 2 position having the amino group, and in one side ethoxy group, so we can say that is for specification in small bracket 2 amino ethoxy, then bracket close, then 1 hyphen 2 amino ethoxy, that is bracket close ethoxy. Okay, so this unit, this ethoxy unit is present in all over the unit, that should be designated by third bracket. Okay, next one, amino ethoxy and ethoxy group, eta this is third bracket. Okay, and if we consider propan, that almost the one compound is propan, this is the propan. Okay, which having the all over the unit, and that should be subdivided. Okay, that also subdivided this, that also subdivided this, that also subdivided this. And for this indication we have to use small bracket, bases and third bracket. Okay. Next one, indicated hydrogen. Sometimes hydrogens are indicated. Indicated hydrogen is also called as added hydrogen, which hydrogens are that should be added in the double bonds are frequently in triple bond. Okay. Is represented in suffix or prefix as locant in the nomenclature of compounds. So there should be, we know that is in rings for planarity triple bonds are not found normally. Okay, as there must be, we have to maintain the planarity, we have to maintain aromaticity, we have to maintain stability. We most of the cases in ring compounds we get only double bond. So double bond, there may be double bond, there may be triple bond, what are they may be, but there should be the chance of addition of hydrogen can be take place. So when addition of hydrogen is take place in a particular position of the ring, so there should be for prefixes in the IUPAC nomenclature we have to use hydrogen. Hydrogen is nothing but that should be denoted, there should be adding hydrogen. Okay. So there must be 4H pyridine, means this 4 position somehow hydrogens are added. So we know when hydrogens are added, hydrogen means what? That is HH are added. If HH are not on there, so we can get this type of compound, okay, pyridine. But due to addition of hydrogen, we get this 4H hyphen pyridine, okay. Similar things, there should be 3H pyrrole. So that must be this 3 position, there should be hydrogens are attached. Next one, seniority of chains. Seniority of chains means when many complex structures are given, how we consider how one in which chain is preferable, in which functional group is preferable, in which ring is preferable, in which term is preferable. Okay, so for this we have to consider seniority of chain to detect the principal chain. Okay, first one, long chain of carbon atoms. We have to consider long chain of carbon atoms. If we consider this type of chain can be there. Okay, and we also consider this type of chain also there. Okay, so there should be the correct destination is 2-ethyl butanol, because in that case we have to consider from starting the chain from OH this side. Okay, then 1 2 3 4, this is the correct chain orientation. We have to consider the functional group, and nearby the functional group we have to consider 1, then 2, then 3, then 4, and this small chain is nothing but this is the branching. Okay, so we can say 2-ethyl hyphen butanol. Okay, we do not consider that is OH, then CH2, then CH, then C2H5. If the other side is longer chain if available, so on that case we have to consider the longer chain, and from that should be indicated from the functional group, main functional group. Okay, so we have to consider the longer chain, first one, and that should be the numbering will be start from the functional group, which is the main. Okay, there should be from that position we have to consider numbering, that is 1 2 3 4 5. We do not go this side because this is the not longer chain. We have to consider this side because there should be the longer chain is there. So the name is 3-methyl pentanol. Okay. Next one, next rule is maximum number of substrate corresponding to principal group. In which chain we choose as a principal chain, there should be maximum number of substrate is present. Okay, so we have to consider correct means what? That is 2-2 chloroethyl but -1,3 diol. So we have to consider this OH as a functional group, that is 1 2 3 4, because this chain is the main chain because it having in 1 position OH and 3 position OH. So maximum number of functional group present in one chain. Okay, so this chain is the parent chain. If in one chain maximum maximum number of substituents present and other chain minimum number of substituents present, we have to consider the maximum substituent having the chain as a main chain or principal chain. So for this case we use that is 2 hyphen at 2 position place, that is this CH2 Cl as a unit. So 2 hyphen in small bracket, the unit will be the unit is written, that is 2 hyphen chloroethyl, then bracket close, then but means this main chain having the 4 carbons, so but hyphen 1,3-diol, because at 1 and 3 position having the OH group, and OH is present in 2 times, so we have to use the prefix di. So 2 hyphen in small bracket the unit 2 chloroethyl, bracket close, then number of carbon atoms but, then hyphen 1,3 position having OH, so we have to use 1,3-diol. That is the correct naming. Okay, but if you consider this, because OH principal group, that's why this is the incorrect. I don't know why this is incorrect. That is the same structures are given. This is also right. Okay. Next one, CH3 hyphen CH2CH, CH3 then hyphen CH2CH2 beer. Okay, 2 bromoethyl butanol. I do not know there, this is missing. There should be the CHO group is there, otherwise butanol not possible. Okay, CHO group is there. Then we can start numbering. Then we can say that is 2 hyphen in bracket 2 bromoethyl then butanol. Okay. Maximum number of double bond and triple bonds considered together. If any chain there should be maximum number of double bond and triple bonds are there, this chain is the principal chain. Okay. So there should be, we have to consider the functional group, and then we start 1, 2, 3, 4, 5, 6. So we have to know there should be 6 carbon atoms, so we can say hexanol. Hyphen 2 in, because 2 position having the double bond and 4 position having the triple bond. Triple bond means YNE, so we can say hexanol hyphen 2 in hyphen 4 hyphen YNE. Okay, and also we can say hex hyphen 2 in hyphen 4 in 1 all, because 1 position having the OH. That also we can retain. We can also retain that is 2 hyphen hexenol. If we combine the double bond and OH, presence of double bond and OH if combined, we can retain that is 2 hyphen H hexenol hyphen 4-wine. This third term, this 2 position designate not the position of OH, this 2 designate the position of double bond. That's why we have to retain 2 hyphen hexenol hyphen 4 hyphen YNE. Okay, so these 3 names are all are correct. We can say hexanol, that is OH is present. We are not mentioning the position of the OH present in what carbon. So we have to consider hexanol at position 2 in, that is double bond is present, then hyphen 4 wine, that is 4 position, that is triple bond is present. Okay. Next one, hex hyphen 2 in, hyphen 4 wine and hyphen 1 all, that is 1 position having the OH group, that also specified. And by omitting the position of OH and combining the OH and double bond, we can say that is 2 hyphen hexenol 4 wine. There should be 2 position designate the double bond, not the OH. Okay. This is incorrect because OH is the principal or principal group. That's why we have to start this carbon as 1, this carbon 2, 3, 4, 5. Okay, 6. Okay. Okay. Next, a maximum length. This chain which we consider as a principal chain, that should be the having the maximum length. So there should be, this is the maximum length because this is having 8 carbon atoms. And if we consider this, so this is not 8 carbon, that is 1, 2, 3, 4, 5, 6 carbon. And this is 8 carbon. So we have to consider 8 carbon, the chain having 8 carbon as a principal chain. Okay. So we have to use 4 hyphen in bracket 2 hydroxy ethyl, because at 4 position 2 hydroxy ethyl group is present. How we conclude 2 hydroxy? Because from that we can start another numbering system, that is 1 prime, 2 prime, 2 single prime, 2 prime. So by this way you can say in bracket that is 2 hyphen hydroxy ethyl, because this is the another numbering system. Okay, start from the branching. So in hypen 2 hydroxyethyl group, and that should be present main chain 4 carbon atoms. So we can say 4 hypen bracket the overall unit 2 hydroxyethyl bracket close. Then 5 octane, because 5 position having the double bond, that is 5 octane. Then 2 1 because 2 position having the triple bond. Then 1 8 diol because at 1 and 8 position having the OH group. That's why we can term, that is, this is also 1, this is also 2. So we can terms 4 hypen, the unit is written in the small bracket, that is 2 hydroxyethyl bracket close. Then 5 octane because 5 position bears a double bond. Then hypen 2 1 because 2 position having the triple bond. Then hypen 1 8 diol because at 1 and 8 position carbon having the OH group. And as the OH group is present in 2 times, so we can say diol. Di as a prefix. Next one, seniority of chain. Maximum number of double bonds. Oh, that should be written. Maximum double bonds that should be present in the main functional group. Oh, sorry, main chain. Okay. If any chain having the maximum number of double bond and other chain having the triple bond, we have to consider maximum number double bond containing chain as a principal chain. Okay. So there should be 4 hypen in bracket 4 hydroxy 2 butynyl, because if we consider start another numbering system 1, this is 2, this is 3. Okay, this is 4. So 4 position having the OH group, 4 position having the OH group, so we termed as 4 hydroxy, and 2 position bears the double bond, so triple bond, that's why 2 butynyl. And that should be present as a unit. Okay, that is also a unit. So we can term as 2 hydroxy 2 butynyl, because if we consider the another numbering system in the branching chain, so we have to consider there should be at 2 position triple bond is present and 4 position OH is present. So by combining these two things, we can consider 4 hydroxy 2 butynyl. Okay. Next one, in other chain there should be, we have to consider from starting from the OH. So numbering system in 1 and then 2, 3, 4, 5, 6, 7. Okay. So there must be 1 and 7 position having OH group. So we can consider 1 7 diol. And there must be hexadiene because 2 double bonds are there at 2 position and at 5 position. So we can say 2 5 hexadiene. Hectadiene because 7 carbons are there. Hectadiene 1 7 diol. So 4 position having the whole over the unit. Okay, at 4 position. So we can say 4 hypen in bracket 4 hydroxy 2 butynyl as a unit. Then bracket close. Then hypen 2 5 hexadiene because 2 and 5 position having the double bond. Then hypen 1 7 diol. Okay, so that should be reminded if 2 chains are there in one chain having the OH group as well as double bonds, maximum number of double bond, and other chain having OH but having triple bond, we have to consider the chain which having maximum number of double bond as a main chain. Okay. Next one, same things are there. Okay, but there should be, this will be the wrong. Okay, because we have to consider this is 5, this is 6, this is 7. This will not considered as a main chain. Okay. Next one, lower locants for the principal groups. There should be lower locants means that is 6 chloro because 6 position having chlorine group. Then hypen 3 position having 1 chloro 3 hydroxypropanol. That is 1, 2, 3. Okay. 1 position having chlorine group in that unit. And that is 3 position having hydroxy group. That's why we term this 1 chloro 3 hydroxypropanol. Okay. So 6 chloro because 6 position having the chlorine group, 6 chloro. Then 3 position having the all over the unit, that is must be 1 chloro 3 hydroxypropanol. Then hept because 7 carbons are there. So hept and 1 5 diol because 1 position and 5 position having the OH group. Okay. That's why hept 1 5 diol. Next, lowest locants for multiple bonds. Lowest locants. CH to OH bond, CH double bond CH. Then there should be 4. We have to numbering system in branching also, that is 1 2 3. Okay, so 3 position be our hydroxy group, so we can terms, and 1 position having double bond. So by combining this double bond and OH, we have to consider the unit as 3 hydroxy 1 propanol. 3 hydroxy 1 propanol, and that justified this main chain having the 4 carbon bears this unit. So we have to written in small bracket the unit, that is 3 hyphen hydroxy hyphen 1 hyphen propanol. Well, in what position? At 4 position of the main chain having the unit. So we have to consider 4 hyphen in bracket 3 hyphen hydroxy hyphen 1 hyphen propanol bracket close, then 2,5 heptadiene, because at 2 position and 5 position having the double bond, so 2,5 heptadiene, because 7 carbons are there, that's why hepta, and diene means the 2 times double bonds are there, so diene, di prefixes attached with in, then 1,7-diol, because 1 and 7 position having the OH group. Okay, and that should be 2 times OH is present, so that's why 1,7-diol. Okay, next one, maximum number of substitution as prefix. So there should be 2,5,5 trichloro-3-methyl hexanol. If maximum number of chlorine group present in the ring, there should be maximum substitution, because this chlorine is present, this chlorine is present, this chlorine is present, this CH is present. That's why this is the main chain. Okay, this state chain is the main chain. But if we consider this chain, so there should be only 1 substituent, 2 substituents are present. Okay, and if we consider this as the main chain, so there should be 4 substituents are present. So what is considered? 4, that should be preference over the 2. So this chain is considered as the main chain, which having the maximum number of substituents. Okay, so by this analogy we have to consider from starting from the OH, that is 1 2 3 4, because the function group in the chain is main is OH. Okay, OH preference over the CH3 and OH preference over the Cl group and Br group also. So we consider 3 5 5 trichloro, because 3 position having the Cl group, 5 position 2 Cl is present, so trichloro, because 3 Cl group is present overall in compound. So we have to first consider the locants, the numbering system, that is 3, 5, 5 hyphen, then we have to consider how many times the functional group is present. There should be 3 times functional group chlorine is present, so we have to consider trichloro, and then hyphen 3-methyl, because as 3 position CH3 group is there, so 3-methyl, then hexanol, because 6 carbon bears the overall the chain, so hexa, and because there are overall 1 OH is present, so hexanol. This is the compound is type of alcohol. Okay, substituent should be in alphabetical order, because we have to consider when we written all of the things, we have to also consider alphabetical order, because 1 2 3 4, 1 is come first then 2, 2 is come first then 3, and as well as A come first then B, B come first then C. So we have to consider if there must be bromine group is present, Cl group is present, so B come first then C, right? B, that should be preference over the C. So we have to consider first 2 3 dibromo. At 2 and 3 position having bromo group, so 2 3 dibromo, there should be MO is missing. Okay, MO is there. So 2 3 dibromo, then 2 3 dichloro, because B come first then C. Then we have to written 5 6 5 5 6 dichloroheptane. 5 5 6 dichloro, not trimethyl. Okay, trimethyl. Okay, so we have to consider B come first then C, then come M. So we have to consider 2 3 dibromo, because B come first, then 2 3 dichloro, then we have to consider 5 5 6 trimethyl. Okay, then lower locants for the substituent in alphabetical order. So there should be, we have to consider 1 bromo 4 chlorobutane, because always remember Br preference over the Cn. Okay, so we have to consider the numbering system will be start nearby of bromine rather than chlorine. If bromine and chlorine is present both sides, we have to consider numbering system start over the nearby of the bromine. Okay, that is, this is 1, this is 2, this is 3, this is so on. Okay, this is the correct orientation. This is the correct orientation, but this is wrong because we start over this side numbering. This is not correct because Br prefers over the Cl. Okay. Next one, seniority of ring system. The last slide, that is seniority of ring system is described by applying the following rules in nomenclature. If there are consecutive rings are there, we have to consider the preferences. Which one preferred more than the other? So all heterocyclic rings are considered as senior compared to all carbocyclics. If carbocycles and heterocycles are there, heterocycle means the cycles which having the heteroatom, maybe nitrogen, maybe oxygen, maybe sulfur, so on. And carbocycle which are considered only there should be carbon or hydrogens and there no heteroatom is present are termed as carbocycles. So that's why pyrrole is preference over than benzene and naphthalene. As benzene and naphthalene correspond, they are goes to carbocycle classification because they are combining of carbons and hydrogen atoms only. Okay. And pyrrole is a heterocycle because there should be still a heteroatom, nitrogen is present. So this is the preference, more preference than benzene and naphthalene. Okay. Next rule, priority of heterocycle rings are based on the nature and position of the heteroatoms. Always remember pyrrole more preference than furan and furan more preference than thiophene. This is pyrrole. This is furan, this is thiophene. Largest number of rings, this having the largest number of rings, so this is preference over than the this. Okay, which having this is there should be three rings are there and there should be 4 rings and there, so 4 rings preference over than 3 rings. Largest individual ring, there should be the preference is this type preference can be shown experimentally. And largest number of atoms in common rings, if common rings having the largest number, there should be three common carbon atoms. There should be 2 common carbon atoms. There should be 1 carbon atoms. Okay. So they are like this of preferences are there. Okay. So next, this is the summary. I have to consider nomenclature in chemistry, that is trivial name like for example Mars gas, vinegar. Some compounds have large systematic nomenclature. In such cases, a short name of compound is given as systematic name, while partial name is also considered as trivial name. Some compounds which having large systematic name, for that cases we have to use some partial name, and this partial name is termed as trivial name. Nomenclature various types. First one, substitute nomenclature, most widely used, and names derived by the substitution of an atom or group that should represent the parent structure. Parent structure already which is there, and there should be some substitution can be take place, some functional group can be take place. Due to this, we have to consider the nomenclature, substitute nomenclature. One group is represented as principal group because this is the predominant nature. This determines all over the numbering system, all over the nomenclature, and called as suffix because the principal group have to be written as suffix and the other rest of the substance are written as prefixes. This is the example, that is 1-isopropyl amino, then 3-1 ethyloxy bracket, then propan 2. So there should be main functional group is all, that is OH, and other prefixes that is others are exhibit as prefixes, that is 1-isopropyl amino and 1-naphtaloxy are present as prefix 1 and prefix 2, but OH is present as suffix. That's why we have to written propan 2 in the first example. Okay. Next one, conjunctive nomenclature, that should be used extensively in USA, United States of America. Useful, which compounds having parent chain carrying characteristic group that should be attached to a ring structure. Okay, there should be hydrogen are lost due to combination. There must be this hydrogen, that is a combination of indole and 3-acetic acid. There should be 2 hydrogens are lost. Okay, this is the systematic name of conjunctive nomenclature, and this is the substituted name. Additive nomenclature, there should be no atoms are lost, may be used to denote addition process. There should be hydroprefixes are used to give the idea there should be addition of hydrogen can be take place in unsaturated polycyclic compounds. As per example, there should be 2H, 3H are given to give the idea there must be addition process can be take place and hydrogens are added. Okay. Replacement of nomenclature. There should be heteroatom present in an integral part of the chain or ring, like for example Q1, like for example pyrrole, like that. Like this type of complexes which having the heteroatom present by replacement of carbon and hydrogen atoms. Okay, and use prefixes denoting the heteroatom that should be present. For oxygen we have to use oxa, there should be X is there. Sulfur we have to use thia, and nitrogen we have to use aja, and phosphorus we have to use phosphor. Subtracting nomenclature. In this system, compounds can be named as derivative of parent compound. There should be subtraction name is there. As double bond is there, we have to use ENE. If triple bond is there, we have to use YNE. Like for that, there must be oxa, aja, because oxygens are replaced by CH2 group. Aja is there because aja, nitrogen is replaced by CH2 group. That's why. Then radio function nomenclature. This is the binomial. The function occurs name preceded by the radical name. If we term their homolytic fission, and there should be CH3 radical, that is methyl radical generated. Due to this methyl radical naming, we have to consider the alcohol as methyl alcohol. If homolytic fission is there, if we consider there should be homolytic fission, imagine, so there should be methyl radical is produced, and due to this naming of the methyl radical, we have to consider this all over the alcohol as methyl alcohol. Locans is nothing but that should be the numbering of the system. That is, there should be 1, 2, 3, 4, maybe A, B, C, D, maybe alpha, beta, gamma. They show only the position of functional group and position of prefixes that should be present in the parent compound. They are placed immediately before these groups to which are related, except in the case of traditional contracted forms of compound. Any compounds have one or more than one ligand, so that's why generally their position can be justified before of the prefixes and as well as before of the suffixes. We have to use locans, and it is not always used. It is not necessarily all compounds having the show the locans. Okay. General nomenclature will be locans, hyphen prefix, hyphen parent, then hyphen locans, then hyphen suffix. So when we have to consider function group, this is the P dominant, so we have to consider as suffix that should be written after the parent compound, and we have to consider there maybe the positions is there, so their locans is termed as before the prefix. Okay, and before the suffix. Okay, and when the other rest of the function groups are termed as prefix, there are also some locans also there, and this locans written before the prefixes. So the order is there, that is locans, then hyphen, then prefix, then hyphen, parent, then hyphen, then locans, then hyphen, suffix. This is the examples also, that is 3-hydroxy, hyphen 2-methyl, then hyphen pen, then hyphen 1-in, then hyphen 4-wine, where in and wine is suffixes and 1 and 4 their corresponding locans. Methyl and hydroxy are prefixes and their corresponding locans are 3 and 2. Okay. Prefixes mono, if mono substitution is there, mono function groups is there, if one function group is there, for showing there one and only one things is there, so to denote the one term we have to use mono. If 2 times any things are there, so we have to consider bi, and similarly if 3 times any function group is there, so we have to use tri, so on. Numerical basis di, tetra, that is also used, and most are Greek derivative except nona and andeka. For 1 number we have to use mono, for 2 number we have to use di or bi, for 3 we use tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona. They are most frequently used. And also 10 deca, 11 undeca, 12 dodeca, 13 icosa. There should be some confusion, that is 30 for, but in book there should be given, that is 14 for pentacenta, 15 for hecta. Numerical, where already their ditries are used, or we can use, that is bis, tris, tetrakis. This is the examples, that is propan 1, 2, 3, that is tris ilium. That is because at 3 positions our ilium group is there, so we have to consider 1, 2, 3 tris ilium. This is the example. Then prefixes bicyclo, we have to consider alicyclic hydrocarbon saturator which consists of two rings only which have two or more atoms in common, so are termed as bicyclo compound, and there should be in bracket maximum number of carbon atoms, then mid number of carbon atoms, then lowest number of carbon atoms. Okay, if there must in bracket is there, so there must we have to written 4 3 1. This is the descending order, not we have to written 1 3 4 are incorrect. We have to consider 4 3 1 for bicyclo compound. But spiral compound we have to consider ascending order, that is 4 then 5. Okay. Then commas. Commas are used to separate locants that are present in the same part of a compound. If in same part two locants are there, for separate out we have to consider comma. Okay, this 1 and 2 are separated by comma. Okay. Colons. Colons are mainly used to separate related set, as there must be 1 1 prime and 4 1 double prime are nothing but that is the linkages of the two phenyl ring. These two phenyl ring linkage by 1 1 prime, and these two phenyl ring are linkage by 4 prime 1 double prime, and that two related sets are developed, and these two related sets are separated by colons. If higher level of separation is needed, on that case also colons or semicolons are used. Hyphen used for separation of locants, used in adjacent locants referring to various part of the name. This is the difference between hyphen and commas. Commas are used for separate out the locants in same part of the name. Hyphen are used to separate out the adjacent locant referring in various part of the name. Used as stereo descriptor and name of the compound. Used in two parts of the designation for a primary fusion site in a nomenclature of a compound for a fusing system, and sometimes longer hyphens are also used. This is the example. There should be hyphens are used in between of to denote that is N is attached with acetyl group to naphthyl group and which is belong to the benzamide system. Okay. Full stop used to separate numerical ring size. Indication is constructed according to von Baer system that should be employed in spido as well as bicyclo compounds in bracket. This is there should be full stops are given. Full stops are given in within the third bracket. Spaces, most important type of punctuation. Punctuation is very important. Then used in separation of more than two function groups. Two function groups there, so we have to use spaces also. Also separate words in additive names. Okay. There was lots of acid and their derivatives. Carboxylic acid, if COOH group is present, so we can term it as acid. If OR, that is COOR group is present, we term it as ester. If COONH2 group is present, we term it as amide. If we see that is C double bond NH group is there, that is termed as imine. There should be anhydride because this group is justified, that is anhydride, acid chloride, and this is succinate because there should be CH2 COO negative and CH2 COO negative anions are there. That's why this is termed as succinate. Okay. Carbonyl compounds, there should be acetone, there should be ethyl methyl ketone. We have to consider that is E come first then M, that is we have to maintain alphabetical order. Acetone oxime, if double bond NOH group is there, that should be termed as oxime. If double bond NH2 group is there, that should be termed as hydrazone oxime, and that is if COO group react and produce, that is OH and CN are termed as cyanohydrin. Okay. Halogen compounds, acetyl chloride, tert-butyl bromide, because this type of group is termed as tert-butyl. Okay. Oxygen compounds, this is alcohol, methyl alcohol. 2 sulfur is attached to it, that should be termed as disulfide, ethyl methyl sulfide. Okay. There should be 1 sulfur is there, that's why ethyl methyl sulfide. Next, italicization in nomenclature. There should be, you have to use that is lower case of italic letters, that is 2-6 numerical position ortho, 3-5 numerical position that is as meta, and 5 and 4 position as para. Okay. Italicized names of element, there should be O is used, N is used, N is used. So that should be designated. This N is present in the, belongs to the Benjamide structure and having one acetyl group and having one Benjamide other structure, and that is H. Okay. So there should be N is belong to Benjamide system and this N is substituted by acetyl group. That should be justified by italicized symbol of elements. Italic element of hydrogen, there should be symbol of hydrogen denote nothing but that is added hydrogen. There should be hydrogens are added. Words and syllabus used for stereo descriptors and structure description. We can use many terms, that is C, trans, R, CT, capital R, capital S, Z, capital E, bis, bicyclo, so on. Importance of vowels. There should be in nomenclature vowels are systematically omitted, as in parenhydrides the terminal E is omitted when followed by a suffix starting with A, I, O, U or Y. So there should be two E and A are not placed together. There should be omission of E can be there, so we get this correct spelling. This is also same. There should be two E, A are not placed together, so this is incorrect. In the Hansch-Widman system, A of an element prefix is added. So as we know, this is the combination of 1 for Thaya and Ajipai's system. So due to this, 2A are not justified, so we have to consider this is the correct spelling. Okay. In numerical multiplication affixes, the terminal A is replaced by it followed by a suffix starting with A or O. That should be, there should be tetraamine. So that is the combination of tetra and plus amine, right? So 1A is omitted. Okay. These A are not justified. This double A are not justified. This is incorrect and this is correct. Annexation of vowel, there should be in some cases O is added. Like for example, this O is added in between of two consonant. In between of H and N, we have to consider this O as a vowel. No effect of vowels in some cases, no effect of vowels can be considered in most of the cases in numerical prefixes, in conjunctive prefixes, in composite prefixes, in fusion prefixes. So this is, there should be no change of the vowel. And this is incorrect. This benzoic acid, that is ZE, is not correct. This is correct. Now order of prefixes. Prefixes are basically two types. One is non-detachable, other is detachable. Non-detachable also divided into two categories. One is prefixes used homo nor for specification or modification of skeletal compounds. Other, that is aja oxa, that should be used the replacement of any carbon hydrogen atoms by these heteroatoms only. Okay, that should be both are considered as non-detachable prefixes. Now we consider detachable prefixes, we have to consider alphabetical order. So there should be 5 come first, then 6, and 1 chloro come first, then 2 chloro. Okay. If there should be ortho, meta, para, there should be preference ortho, then meta, then para. We ignoring all of the numbering system. So we have to consider first ortho methyl phenyl, then meta methyl phenyl, then naphthalene. We have to consider ortho first, then meta. Importance of bracket, that is small brackets that should be used for defining substitute as substrain. We can use after using B strings. The unit are enclosed in the small bracket and placed around simple substrain prefix to separate locants to avoid ambiguity and for acid clarity. There should be chloromethyl placed in the small bracket for specification. After B's, we can use first bracket 2-hydroxymethoxy. As 2-hydroxymethoxy group is present in 2 times, so we have to written B's in small bracket 2-hydroxymethoxy. Then acetic acid. Square bracket, that is should be used. Square bracket is used to enclose description denoting fusion site. Okay, 2 rings are fused together at that position can be designated by square bracket. Used in some spiro compound as well as bicyclo compound and to enclose locants for structure feature of compounds, to indicate repetition of group of a chain, placed to enclose subsequent prefixes in which small brackets or curve have already been employed. There should be fusion sites are designated and there should be bicyclo and spiro compound having the number of carbon atom present in any site of the chain can be designated by the square bracket. Bases are used. Bases are used when may be employed to enclose substituent prefixes in which square brackets are already been used. Already a square bracket and small brackets are used, so we have to use bases. Indicated hydrogen, hydrogen is used as added hydrogen in atom, is represented in suffix or prefix as locant in the compound. So there should be 4H means what? That is at 4 position hydrogen is attached or added. There should be similarity of chain. We have to consider first long chain of carbon atoms, that is if there is so many chains are there, we have to consider longer chain first. Then maximum number of substituents present in a particular chain, that should be considered as principal chain. If there should be so many chains and one chain having the maximum number of substituents, that should be considered as principal chain. Maximum number of double bond or triple bond considered together. There should be, if any principal chain having the maximum of double bond and triple bond, that should be considered as principal chain. Maximum length will be there in the principal chain. So there should be maximum number of double bonds. There should be triple bonds are there, and there should be maximum number of double bonds are there. Superiority is double bond. So we have to consider the parent chain which having the largest number of double bonds are considered as main chain. Lowest locant for the principal group, there should be lowest locant. We have to consider this chain as a secondary chain or branching. Lowest locant for multiple bonds, okay, and maximum number of substitution as prefixes. In that case, there should be in that chain having the 4 substitution, so that should be considered as main chain. And if we consider this chain, so this is having only 3 substitution, so this is not a main chain, okay. So we have to consider this as a main chain. Then substituent in alphabetical order, we have to written B come first, then C, then M. So we have to consider first 2,3 dibromo, then 2,3 dichloro, then 5,5,6 trimethylheptane. Okay. Next one, always remember that is Br preference over the Cl. So we have to consider the numbering system will be start over the nearby of Br rather than Cl. So there should be numbering system start over the nearby Br. So if similarity of ring system, if so many ring cycles are there, we always consider heterocyclic rings are preference over than carbocycles. Okay. And priority of furan, pyrrole, thiophene, this is the order. Largest number of rings preference over the smallest number of rings. Largest individual rings are preference like this way, and there should be largest number of atoms in common rings. Okay. Okay, thank you.